Yeah, good evening. Hello. Can you hear me? Am I audible? Okay. Thank you, Ravi. So we'll start in a few minutes. Okay. So if you have any doubt, so from the last session, please let me know. Okay. So we can discuss for first few minutes about the last session. I mean, if we did some double integrals, beta function, gamma function, and all. So if you have any doubt from those session, then you can ask me. Yeah, I will wait for some time. Yeah. So Ananya, if you have any doubt from the last session, then you ask me. Okay. So we are waiting for the few people to join, and but before that, if you have any doubt, you ask from the last session. Okay.
No doubt, sir.
Okay. Skin is visible, right? Screen is visible.
Yes, sir.
Okay. So yeah, this is your uh, tutorial of week 8. Uh, this is Rahuldev Ghorai from ISO Tiruvananthapuram. Yeah, so we'll start. As you don't have any doubt from last sessions, I kept this blank papers for the last session's doubt. So yeah, so these are the topic for today's discussion. I mean, question answer will be done from this four session from these four topics. Okay, first one will be system of linear equations. All of you must know the what is actually system of, I mean, what is linear equations, and then the system of linear equation. You take two, three, more than one linear equation, that is a system of linear equations, and system of linear equations. Then the linear algebra will little bit have vector space and linearly deep independence of vector. I mean, everything is just for to solve the linear system. Solve linear system, and then the linear algebra little bit will be there. Okay. So yeah, so is it? I mean, do you already gone through the lectures, whatever he has done? You know the theory, or I have to do little bit theory. Whatever you prefer, I will go through that. I mean, if you know little bit theory, then I can start straight away. Start with question answers. Otherwise, we can do little bit of theory. I mean, like we do usually.
So a little bit of theory.
Okay. So anyone joining or anyone is messaging the chat box, please tell me. Okay, please keep some work. Okay, so Ravi Shekhar, if you don't have any issue, then try to speak instead of messaging. Okay. Anyway, no problem. So yeah, so system of linear equation. You see, I wrote something today for today's session. So mainly for the solving the linear system of linear equation, you need to know few things. Then your life will become easier. Okay. So that is first of all why I am starting with matrix, that we will understand better. So first, let's start with matrix. You know what is matrix? First of all, is the matrix is, when a matrix is there, then what you do, we perform like to calculate row, we perform a row reduction, something called row reduction. We do if first of for this example, let's say you have an example like this 1 2 3 2 4 6 3 6 9, one example. So we try to reduce the matrix to some other matrix where it will look very like easy, and like how it will look like, it will have, if some row has a, I mean, non-zero entry, then below those, that non-zero entries, the first non-zero entry of that row, and the below that everything, all other element will be zero. I mean, what I mean is, I mean, if you have suppose 0 1 0, the first non-zero element in this row is 1. So after this row, after that element in that column the other elements would be 0. And if suppose this is here, it is 1, then the other element, the below that, has to be 0. I mean, you have to make sure that the matrix looks like, I mean, matrix somehow becomes this. When one non-zero element is there, the below elements, I mean, all the elements in that column will be 0. Here you see, you have this matrix A, okay? This matrix A. So when you have A, if you subtract 2 times the first row from the second row, so what it will be? So if you 2 minus 2 times 1, and 4 minus 2 times 2, 6 minus 6, 3 times 2. So if you do the, I mean, we denote this row operation. Row is R2. What is R2 row? R2 is nothing but 2 4 6 row. So I mean, this row bracket, right? So what I do, R2 minus 2 times R1. So this operation we can do. These are the things you have to know. This operation we can do. So when you do that, I mean, you name the new R2 as like this. R2 prime will be R2 minus 2R1. So that becomes 0 0. This is your R2 prime. Similarly, if you make R3 prime as another row, that is R3 is equal to R3 minus 3 times R1. So what will happen? 3 minus 3 times 1, 6 minus 6 times, sorry, 2 times 6 minus 3 times 2, 9 minus 3 times 3, right? So all of them will be 0. So that's how you get this one also as 0, right? So I mean, and you see whatever I told, this when one first non-zero entry, we don't really bother about second non-zero entries, okay? So so here it is happening, but second non-zero entry you don't need to check about that. But when you have first non-zero entries 1, the below two entries are 0 0, right? So this is your first non-zero entries, and then the two entries are non-zero. So then that type of form will be called row echelon form, and the after reducing to that matrix, whatever the number of non-zero rows, the number of rows will be not column, number of rows. So because you are doing here row reduction form, so number of rows will be the uh, rank of the matrix. So here that is how rank of a matrix is, this matrix is 1. So now you try to find out, at least tell me how what will be the, I mean, say, let's say you have 2 3 4 5, what will be the rank of this matrix, and what will be the rank of this matrix? 4 6. This is very simple here. So we try to transform this matrix to row reduced form of this matrix. What you will do? I mean, I want to find out the rank of this matrix. So anyway, rank is already done in the class, right? I mean, is it in the syllabus? Sometime it may happen that it's not in syllabus. It's in syllabus. Ananya and Ravi. He has done, right? using rank only you can solve the linear systems, right? System of linear equations. It's not it.
Yes, sir.
So then you need to know the rank. So is it going? I mean, is it a little bit difficult you feel, or like you tell me? I will try to make it a better way. I mean, to solve a linear system, so linear system corresponds to a matrix. Okay, that we will see. And that matrix, you need to know the rank of the matrix. Then everything is done. After that, you don't need to do anything. I mean, you just don't need to check anything else. You just solve the, I mean, find out the rank. So here you see what I will do here. Here is 2, 3, 4, 5. Okay. So always this one is already non-zero is there. So I will try to make. I'll try to make. Sorry. Yeah, I'll try to make this quantity 0. Okay. So what I will do is this operation. What I will do is R2 minus 2R1. So what will make that? That will make this 4. This will be 4 minus 2 times 2 and 5 minus 3 times 2, right? That is nothing but 2, 3, 0 and minus 1, right? So then what will be the rank for this matrix? So first of all, did you get the row reduced, I mean, row echelon form? Because you see the first non-zero element, first non-zero element in R1. What is R1? I mean, this is called R1. This is R1. Okay. This is R1. So R1, first non-zero integer R1 is 2. And you see the below 2, all the elements are 0. Right? There is nothing non-zero is there. So that is there. And another one will be the first non-zero element in R2. What is R2? This is called R2, right? R2 is minus 1. That is also non-zero element. And below that, nothing is there. So you can imagine that is not a problem. So, I mean, two things are there already. I mean, everything is okay. I mean, it's a row echelon form. So, the number of non-zero row, how many number of non-zero rows is there? Number of non-zero rows is equal to 2. So that is equal to rank of the matrix. So rank, that is equal to rank of the matrix. So that's how we can. So here also, if you understand this, then you can easily see that this you can, if you R2 minus 2R1 is the same type of operation you can do. Then 2, 3, 0, 0. So which will give you this first non-zero element, below that it is 0. So one non-zero row is there. So rank is 1. Understand? These are some very simple example I took for your understanding, better understanding. So that's what you need to know. Even if you understand this thing, then I mean almost 80% of today's session you can do easily. So what I will ask you whether you have understand this. I mean this what we have done is this too. I mean you have a matrix, you try to reduce to reduce that matrix to a row echelon form, something called row echelon form. That is this type of thing. I mean you find out if you have to make sure that after transforming the matrix the entries, the first non-zero entries, you find out the first non-zero entry of a row, and in that after that element in that same column the no non-zero elements are there. I mean if you have two, see 0 is there. I mean no other non-zero elements are there. So I mean below the element, that's something called, these are something called pivotal element, something called pivot. So that pivot element, I mean, below that, I mean, pivot element means below that has to be zero element. So each non-zero element, non-zero row should have a pivotal element. Or if you find out a row, so in each row you have, if some non-zero element is there, below that everything should be zero. That's all. That's the thing you have to do. So you understand?
Yes, sir.
Okay. Abby?
Yes, sir.
Okay, good. So then we'll move to the next part. So something I wrote here. There are something. I mean, I will share anyway this PDF. So row echelon form of a matrix and something or reduced echelon form of a matrix. So this one will not do today's in today's session. So if you want, you can study, you can read this, but we don't need it in this session. Okay. So in any non-zero row, the leading entries first non-zero entry is 1, so that may not be always, I mean, that is, it can be non-zero element. Okay, so you can make it 1, it is better, but otherwise it is non-zero also fine. So if row k has a leading entry, then either leading entry in row k plus 1 is to the right of one of row, or k plus 1 is 0. All row with non-zero entries for only zeros for entries are at the bottom. Okay, I mean, this is whatever I said here, this is, so you, if you don't, this one, if you don't want to start that, you don't want to read, leave it, but you have to understand whatever I told here. Okay, the example, this one and these two. Okay, so these are written in some literature, like that's what I wrote it here, but you have to understand in a like better way, that's why I gave all these things. So now we come to a system of linear equations with very easy examples. You see here we have x plus y equal to 2 and 2x minus y is equal to 1. So see, any system here, this one you can write as ax is equal to b, where a is a matrix 1 1 minus, sorry, plus 2 minus 1, and x is equal to xy, and b is equal to 2 1, is not it? So if you multiply a times x, what will happen? 1 1 2 minus 1 times xy, which will give you x plus y 2x minus y. And when you write ax equal to b, that is nothing but that implies x plus y is equal to 2 and 2x minus y is equal to 1. It's not it, because b is equal to 2 and 1. So that's how any, I mean, this is a very I mean, a small example where you can see any linear system. Like from here, you can observe that any linear system you can write as a like ax plus ax equal to b type of thing, where a is a matrix. I mean, ax b all are matrix. When x and b are vector, but vectors are nothing but matrix. Okay, they are, I mean, matrix of like only the only one column. Okay, so yeah, so now we come to like when the system of linear equations will have uh, no solution, when it will have infinite solution, when it will have unique solution. Only these three cases can happen for a system of linear equation. It can happen that it has unique solution. So first example is that. So what you do, so you try to find the augmented matrix. Okay, so I will yeah, so let me write it. I mean, you have this x plus y is equal to 1, so what you can write, 1 times x plus 1 times y equal to 2, and 2 times x plus minus 1 times y is equal to 1, right? So coefficients are 1 1 2 minus 1, and we'll take this one also, this one here also we'll take. Okay, so then we'll find this will be one matrix. So this matrix, so if you forget about this line also, no problem. Okay, So this line is just keeping A separates B. But while thinking about this matrix, this will be one big matrix like 1, 2, 1 minus 1, 2, 1. Now we will try to find out the rank of this matrix. Okay. So like we usually do, right? How we will do? So here you see 1, 2, 1 minus 1. So suppose this separation is there, then 2, 1. So this matrix is A matrix, and the whole matrix is A augmented B matrix. Okay. So now if we perform a row echelon form, for a row echelon form, what you will do? R2 minus, here also you see R2 minus 2 R1 you have to do, right? Then what will happen? Sorry, not 2 R1, half R1, right? 0.5 times R1. Then what will happen is 1, 1, 2 will be there. So the change will be in this R2. R2 will be, sorry, R2 minus 2 R1 only, right? What I mean? So R2 minus 2 R1. So that will make this one is 0. This will be minus 3 because minus 1, minus 2, minus 3. This will be also minus 3, right? What is the rank of this matrix? Anyone? What is the rank of this matrix?
2.
So rank of augmented matrix. This is whole matrix, is 2. So can anyone tell me here also what is rank of A? Even from here itself, rank of A. What is rank of A?
2.
2.
So rank of A is also 2, right? Because if we don't take this 2, 1, so then 2 minus 3 won't come. But otherwise also it is 2. Rank will be also 2, right? So rank of A is 2, and rank of A the augmented matrix A separate B, that is also 2, and that 2 is the number of non-zero rows. I mean, the rank of A can be maximum 2, right? So number of non-zero, so the number of non-unknown, so that is equal to also number of unknowns. So in this case, when this happens, we will say that the system has unique solution. Also here you see, you will find out only this will be x equal to 1 and y equal to 1 will be the only solution. So what is the criteria? So this is the criteria for any system. So for any system, if you have, you can find out the rank of A separate B equal to rank of A, and that is also equal to number of unknowns. Okay, that has to be also equal to number of unknowns. So if that is not equal to number of unknowns, that can be strictly less than. So if, I mean, it is unique solution. So when you have rank of A separate B equal to rank of A, but that is strictly less than number of unknowns number, then no solution. Okay. So the three cases I will be just writing here. By a small example I started, rank of A separates B is not equal to rank of A, then sorry, I made a mistake. I'll just rectify myself. I mean, I'll just tell you. So this case will be no solution, and here it will be infinite solution, infinitely many solutions. Okay, so these are the three cases. So first of all, you need to know about rank, and then these three are to remember. Then 80% of the lectures will be done. I mean, no need to do anything else. Okay, so see, let's see, we using these three, whether we can find out x plus y equal to 2, and I mean this example, okay, x plus y equal to 2 and 2x plus 2y is equal to 4, whether it has infinite solution, that you can see. So the matrix will be like this: 1 2 1 2 1 1 2 2 2 4. If you take row reduce, you want to change it, then R2 minus 2 R1. If you do that, the matrix will change to 1 1 2 0 0 0. Here you see, the if you take A matrix, I mean the matrix A here, and the matrix A separate B, both will have rank 1, but rank is 1, which is less than number of unknowns. Number of unknowns are x and y, 2. So number of unknowns are 2, but the augmented matrix and the matrix has the rank is 1, which is less than 2. So it will have infinitely many solutions. So it will come to this uh, uh, case. So that it will not have. So it will have infinitely many solutions. So no solution case, let's say. So no solution case, we say that it is an inconsistent system. Okay. So no solution. So what is the matrix? 1, 1, 2, 1, 1, 3. So if you do a row reduction, so that what will happen? R2 minus R1 if you do, then 1, 1, 2, 0, 0, 1. So can anyone tell me what is the rank of A and wrong? Or say, let's say I take A is equal to this matrix. A is equal to this matrix, and A augmented B is the whole matrix. Okay. Then what will be the rank of from here itself? From this one, can anyone tell me what is the rank of A and what is rank of A augmented B?
Sir, for A it is 1 and for A augmented B it is 2.
Great. Okay, so yeah, that's correct. So Ravi is also, I think, yeah, you wanted to tell this only.
Yes, sir. Got the point.
Yeah. So then it will come to this case. This case. So what does it imply? There is no solution, right? So it becomes very easy. See, with this very easy examples, I hope I could like make yourself understand that how you can find whether it has unique solution, when you have ununique solution, when you have no solution. So first, let me know whether you have understand this fully. Then we'll go to, I mean, there are some examples will be there from your assignment and all, which you can do then easily. I'll give you some time, you do, and then we will again try to do and review this.
Sir, sometimes your voice starts going very low, sir. I don't know whether it's on my side or.
Okay, another Ananya is there. So can you tell whether my voice is getting
Yes, sir.
low?
Sometimes in between it gets slow.
Oh, I mean, it's frequently, the once it happened or what?
So it happens in some times, sir. I mean, it's not always, but in between, it happens.
Yes, sir.
Oh, okay. Then it's, I don't know what is the problem.
So maybe the mic issue. Maybe you are sitting a bit far from mic. Maybe.
Oh, I see. I mean, can you see, can you like hear now what is
Yes,
okay?
sir. Yes, sir. It's fine, sir. Right now.
Okay, okay. Please let me know. If stop me, no problem. Yeah, I can't hear you. At least tell, okay? I'll understand
Yes.
then when it is happening, okay? Yeah, might
Sir,
be I
I
will.
actually
Yes.
had a doubt about the rank. Sir, not in this course, but apart from that, like in school and college, for example, I knew that when we want to convert the matrix into echelon form, then
Yes.
there is something that in every row there should be something to do with that the number of zeros before the first non-zero element should keep increasing as you go down, something like that. So is that also applicable?
No, no, no need to that. That's what I said. It is reduced row echelon form. Something called reduced row echelon form and something called row echelon form. So for the for your rank, you need to know only row echelon form. So that's what as a row reduced echelon form is not needed. Okay.
Okay, sir. Okay, sir. Thank
So
you.
okay, no problem. Yes. So yeah, let me know if any doubt is there. Otherwise, yeah, we'll move to some assignment questions. Anyway, so the most important part is, I think, if you got it, then like it was this most important part was the whatever we have done already, the theory and the little bit small examples, easy examples. So I'll give you this question. So don't look at. So did you get you get assignment solutions also PDF?
Yes, sir. We just got them now only this week. I think past 2 3 days we got the PDFs for all the assignments from week 1 to week 7.
Okay, so week 8 assignment you have, right? Week 8 assignment.
Yes, sir. Assignment we have.
Okay, you don't have any solution, right?
No, sir, because I think the due date would be around on Wednesday or Thursday. That's why we don't have the solution
Okay,
there.
okay. Okay. So anyway, then yeah, let us do that. This x minus y plus z equal to, let's say you have 3. Is it okay? You want to try this type of questions? I mean assignment questions? No problem, right? I mean, or you want to try some other questions than assignment questions? I don't understand whether what you want. I mean, what you would like to do. I mean, this is whatever I did till now. That was not from assignments. It was for understanding something. Now it is an assignment question, but which will depend on the whatever we have done. Using that, you try to do whether it has unique solution or it has so unique solution, or I mean infinitely many solution, infinite solution, or no solution. So mainly what you have to do, this you have to write as ax equal to b, right? And that you can always write. And then ax equal to b, where a will be, how it will be? A will be 1 minus 1 1, 2 minus 3 5, 5 minus 2 minus 4, right? And b will be 3 8 and 9. So now try to find out the, I mean, a augmented b will be then 1 2 5 minus 1 minus 3 minus 2, 1 5 minus 4, sorry, another entry will be there, I mean 3 8 9. Okay, so now tell me, like, rank of the gives up to this you have to do, then find out the rank of a and rank of a augmented b, and tell me like what, like the system, whether system has unique solution or no solution. Try, at least try, and give me the row echelon form of this matrix. Okay, I'll wait for some time. Yes. So you got it or? Okay, so let me do at least maybe the first one, then another one you can do maybe. Okay, if you haven't done. So first, what I will do, R2 minus 2 times R1 and R3 minus 5 times R1. Okay.
Sir, unique solution.
Okay. We'll see. What is the thing? So another. So Ravi, what you got?
So I got infinitely many solutions and rank as 2.
Rank of like let me write. So rank of
A and rank of AB both are true.
both are two. Okay.
2.
Yes, I understand. Go with two. So less than unknown. So you got this. Okay. I mean, I am
Yes,
not
sir.
telling it is correct. Okay. We'll see what is coming and what uh, what Ananya got.
Sir, I got rank of A and A augmented as 3 and so unique solution.
So is equal to 3 is equal to rank of the other is so unique. So okay, we'll see that. Okay, what is coming. I am doing so. You check where you are making mistake. Okay. Yeah. So yeah, if I do this, then what will happen? I mean, what will be the first entries are 0. That is not a problem. First entry. So I keep minus 1 and 3. This will be as it is, right? And then this quantity will be 0. This first one will be 0. Second one, I mean, there's 3 minus 2, that will be minus 1, and this one will be 3, and this will be 8 minus 6 is 2. And R3 also I make minus 5, so that makes it 0. Okay, and plus 5 minus 2 is plus 5 minus 2 is 3, and minus 9 and minus 6, right? 9 minus 5 into 3, 15, so that will be 6. So now what happens, in the first row you have the first row, the non-zero element is 1, and below that non-zero element everything is 0, so not a problem. But you see in the second row non-zero element is minus 1, but below this one, below that is not a 0 element. So what we'll do, so for that, to make 3 as 0, what will happen? What you have to do, say R3 minus, sorry, plus 3 times R1, sorry, R2. If you make this change, what will happen? 1 minus 1, 1, 3. So this will remain as it is. R1 also will remain as it is. Sorry, R2, that also will keep as it is. And R3 will change to 0, and 3 plus 3, that will be also 0. And if you take this one will be also 0. So, right, this one will be 0. So now it is row reduced form, right? Now it is row reduced form. So having row reduced form, rank of A means this, for this rank of A is equal to 2, and if you take augmented matrix also, the rank of A augmented B also 2. So solution, I mean infinitely many solutions. So this will have infinitely many solutions. So you can check that also how it is infinitely many solutions. Okay, I mean there will be you can, if you try to solve this system, you will see like more than one solution will be satisfied by this system. Okay, so yeah, if you had made mistake, you try to rectify. Okay, try to understand where you made mistake, and let me know whether this is correct. You can do in different way to get this type of form. Okay, this type, anyway you have to come back to, I mean you have to get this type of form. So it can be different form. For your calculation it can be different, okay, but it should have, if the first non-zero entries is there in a row, then the below that other elements are zero, that you have to make it, okay. Okay, is it okay?
Yes, sir.
No problem. You made you understand, right? Fair was the you
Yes,
made.
sir. I think I did the same operation. I think I must have made a calculation mistake somewhere.
Oh, no problem, no problem. But if you understand, that is good, okay? No problem.
Yes.
Let us do the other question, then you can understand what is going on. Minus 4y plus 11z is equal to 19. 5x plus y plus 4z is equal to 2. 3x plus 2y minus z is equal to 5. Do this one. I'll wait for your answer, okay? Do it, no problem. I will do again. So that's how we will learn, okay? One minute, wait. Okay, so Ravi is telling something and no solution. Okay. Ananya, are you doing or?
Sir, I'm still doing.
No problem. So we'll take in 1 or 2 minutes. After that, I will also do. Let me write at least the augmented matrix. Ravi, please wait for some time. I mean, you will get answer. Like what I will also do, and then you will understand whether you did correct. So this will be 1, 5, 3 minus 4, 1, 2, 11, 4 minus z, 19, 2, 5.
Sir, it should be -1. You have written -z.
Sorry, minus z, yeah, it's just looking at the equation I was writing minus. So minus z, okay, minus so minus z, this is 4. Yes. So what is the at the end what you got, Ravi?
So the final matrix,
Yeah, final one. Final the
sir, row wise 1, -4, 11, and 19.
okay.
Second row 0, 21,
21.
yes sir, 21, -51, -93, so -51,
Yes, yes, I got it. Minus 51.
-93,
93. Okay.
and third row
0 should
triple
be
0, 0, 0, 0, and last one is -10.
minus 10. Okay, okay. Yeah, yeah. If I mean it is row, I want to know whether you got the row echelon form. At least this looks like row echelon form. If you made some mistake inside that, I don't know. But yeah, this is. I mean the process is correct. You are correct. I mean, we'll see. I mean what type of things we get. Like 1 minus 5. I mean I will do from row echelon matrix. So let us change it. I mean if I do R2 minus 5 R1, then you will have 1 minus 4, 11, 19 is there. To be 0. Okay, 21, yeah. So minus 5 means minus 55, so minus 51. So yeah, minus 93. And again, I will do this as a 3 R3 minus 3 R1, that will be 0. Minus 3 R1 means 12 plus 2 is 14. And then, yeah, minus 34. And then, so 3. 57 means minus 52, right?
Yes sir.
And then if I do 14 minus
So 2 by 3 of
14 by 21 times 21, I mean 7, 2 by 3, okay? So
yes sir.
what I will do after that, uh, 3 minus, I mean I have to make 14 as 0, and 14 has to be changed to 0, R3 minus 2 over 3 times R1, right? Then it will be what? Yeah, I think you were correct.
Sir,
So
R2 sir, 2 by 3 of R2.
R2, yes, R2, true, R2. I mean, that's what I did here, 14 minus this one. So it will be R2, and then it will be 1 minus 4, 11, 19, 0, 21 minus 51 minus 93, 0, here it will be 0, and here it will be some non-zero number, I mean, some, sorry, 0, not 0, it will be 0, 2 by 3 times, and then minus 34 plus 2 by 3 times 51, so 3 times 17, so that will be 0. But here it will be 0, but it will be in some non-zero number. So you see the matrix of rank of this matrix is 2, but if you take rank of this whole matrix, I mean from here to here and take from here to here, A augmented B, that will be, I mean this is 2, this will be 3. If you take the augmented matrix, the number of non-zero row will be 3, right? This one also number of one non-zero row, this one non-zero row, this one is non-zero row. This one is non-zero row for A augmented B, but 0 row for yeah, I mean the matrix A. Please mute yourself. Okay, so I muted the student. Okay, so now you understand this one? Is it okay, right?
Yes.
No problem? Okay, so now I think in this direction, there one last question will give, because otherwise you will get bored. I think the same question always. So I'll give one question which will, so for like find the value of k for which the system I am writing x plus 4y plus 2z is equal to 3, 2x plus 6y plus 7z is equal to k, and x plus 2y plus kz is equal to 2 will have infinitely many solutions. So this will be the, I think, last question for this in the system of linear equations. System of linear equations. Okay. So, but you do it. I'll give some time. I mean, you can take whatever time you want. I mean, not more than 6 minutes, 7 minutes. But yeah, I try in 5-6 minutes. Okay. And tell me the values of k, also the matrix and all I will ask, and then I'll discuss. After that, I will move to the linear algebra. I mean the vector space. Okay. Please do this. Okay, I will wait for others' answers. Okay, so both of you got k equal to 5. Okay, that is then might be the thing, the solution might be the might be k equal to 5. Okay, so first of all, let me know what is the augmented matrix you got. I mean, the after reduction, I mean, after reducing, what you got? 1, 4, 2, 3, then other two entries.
0, -2, 3, k minus 6,
K minus 6, okay.
0, 0, next line, k
0,
minus 5, 5 minus k.
5 minus k.
Yes, sir.
Okay, I see. Yes. Then,
Sir, I
yeah,
got very different answer.
yeah. Tell me what you got. That means A augmented B. We'll
Sir,
see.
1423
Yes.
02
0, 2.
7 minus 2k. This is 7
Step.
minus 2k.
Okay.
Yes. K minus 4.
Okay.
0 0 5 minus k and k minus 5.
Okay. So let us do whether you have done correctly. Okay. So let me tell me what you have done. So let me write first the what is the augmented matrix. So you will see whether you made a mistake here. Okay. 1, 2, right? Not 4, right? 1. No, sorry. What am I writing? This 1, 4, 1, 4, 2, right? 3, and 2, 6, 7, k. 1, 2, K2. Now Ananya, first tell me, so like what you made, like what is the change you made here? R2 minus 2 R1, right? Or what you would have?
I did R3, sir. R2
Okay,
minus
no problem, no problem, no problem. R3 minus R1.
no, sir. R2 minus 2 R3.
R2 minus 2 R3.
Yes, sir.
Okay, that is also not a problem. Let's see after doing that also what happening. So R2 means that change will be in R2, right? R2 minus 12 means 0, 2, 7 minus 2k. Okay, that's how we are getting 7 minus 2k. Then k minus 4, right? That's what we got. Okay, I think you also might be correct. That's what I told initially also. You can get two different type of matrix after reducing, but the properties should be same. See, for both of you, the properties are same. Most probably both of you are correct. So we'll just cross check it whether correct. Okay. Then what you did after this? Hello.
Yes, sir. I did R3 becomes R3 minus R1.
R3 minus R1. Okay. We always understand that when I am writing R3 minus R1, then R3 we are changing. So you can write or you may not write also not about that R3 equal to R3 minus R1. That thing you may or may not write. So 0 to 7 minus 2k, k minus 4, it will be 0. R3 minus just R1 you are writing.
Yes, sir.
So that will make it minus 2,
Yes,
k
sir.
minus 4, and minus 6 is minus 4. Okay. Then
Sir, k minus 2 in the last row.
Yes, sir. K minus 2
sure,
and
sir,
at
k minus 2,
minus
k
1
minus
at
2. Yeah, I thought it's 2. It will be minus 1 then. Yes, minus 1.
yes,
Okay.
sir.
Yeah, true. Then
Then I did R3. No, R3 is equal to R2 plus R3.
okay, I mean 4, 2, 2, 7 minus 2k, 3, k minus 4, 0, 0. Okay, 5 minus and k minus 5. Okay, yeah, then I mean, sorry, not k minus 5. Yeah, k minus 5, yes. Yes. So yeah, now what is has to happen if it has infinitely many solutions, rank of this quantity and rank of this has to be same, right? And so when k is equal to 5, then the rank are same, right? Also when k not equal to 5, then also rank are same. But in this case, the rank when k equal to 5, rank of A is equal to rank of A augmented in B, that is less than number of unknowns, right? And in this case, rank of A is equal to rank of A augmented B, that is equal to number of unknowns, right? So that's why in the when k equal to 5, see in the both cases actually the rank are same. It is rank A or of A equal to rank of A augmented B. But the first case number of unknowns are 3. So in the first case it is less than number of unknowns. So that's why in that case only this will have infinitely many solutions. So when k equal to 5, this will have infinitely many solutions. And this one, I mean the one which Ravi did, that is we can easily verify that it will be coming like this. See, because 2 minus will be 0, and then I mean this is the matrix 4 minus, I mean if you make this k minus first 2, and then you make I mean first you do 2 minus r2 minus 2 r1 and r3 minus r1, right? That's how you did, Ravi. R2
Yes,
minus
sir.
r1 and
Yes, sir.
IV2. Okay, first. Okay, so this will be, it's like this only. Okay, So I mean, yeah. Now it's. I think both of you well understood. I think I hope so that they well understood this. How to find out a system has whether it has infinitely many solution, whether it has unique solution, or whether it has no solution. Okay. Yes. So and where was those? Yeah, these were the three rules. You can check. I will upload this PDF. You can go through it. These are the three things where we have discussed about those. So now we'll move to now. Then is it okay, right? Now we can move to some other topic because this. I think I hope all of you understood. And assignment there are many questions. I think both of you can do all the assignment problem. What like from this topic? I mean, whatever we have done in this no solution, all the questions you can do now. I think it will be very easy now because almost all the other questions. I mean, the questions we did those were difficult maybe. So yeah, I will leave this here, I mean this topic here. Now we'll go to the vector space. Okay. So all of you know the vector, what is vector space, right? Can you quickly tell me what is vector space? What is vector space over set of real numbers? What's a vector space? I mean, I don't want maybe the precise definition. At least tell me what are the operations or I mean, yeah, so the core of the vector space. What should be there?
Sir, if you can give the overview, sir, it will be better, sir.
Oh, no problem. Okay. So a vector space, usually you will see the vector space has to have zero element. Vector space has to have zero element in the if we say V is a vector space. V, let me write it properly maybe. V is a vector space over a set of real number R if group for all. I mean, I should not do all those things also. I mean, let me not write precise definition also, but this one also kind of precise. I mean, if for all a b belongs to V, a plus b belongs to V, and zero element also has to be in V. And second one is for all A belongs to V and constant C belongs to R, C times A, we will multiply that, that also has to be in V. I mean, let's say set of, you have set of real numbers. I mean, not set of real numbers. Yeah. I mean, you have in R2 is a vector space over set of real number R, because if you take any two numbers like 1 2 plus 3 4 and we define addition like first component wise addition, that will be 1 plus 3 is 4 and 2 plus 4 is 5, so that is also in R2. If you take any two element like this, so x1 x2 and plus y1 y2, two element from R2, then x1 plus x2 again a real number, so x1 is real number, another x2 is real number, that's why x1 comma x2 is in R2, and here x1 plus x2 is in R2 and y1, sorry not x1 plus x2, I am doing component wise addition, right? So that should be then x1 plus y1 and x2 plus y2, that is also in R2. And if I take any, suppose let's say 5 times x1 comma x2, 5 is from set of real number. I mean that has to be from the over the space, that space, that is equal to 5x1 comma 5x2, that is belongs to R2, right? So R2 will be vector space over set, and also 0 element here is 0 0, that is also in R2. So at least you remember these three. Have addition, so any two, take any two numbers, and if you add it, that has to be also again in the same space. And then another one will be the over the vector space. When you talk, vector space will be always over set. So that set, if you take, you have to multiply by the element of that set. But again, that element, when you multiply with any element of the space, so that element has to be also in the same space. Okay. So and 0 0 element has to be in the R2. Okay. So I'll tell what exactly, I mean, how exactly you can. Let's say, do you know set of irrational numbers? I mean, which is, I'll give you an example where it's not a vector space. Q is not a vector space over R. You know, all of you know what is Q? Set of rational numbers. I mean, the fractions A by B type of form, right?
Yes, sir.
Okay, so Q is not a vector space over R. Why? Any example quickly? See, if you take A, B from Q, then A plus B will be also in Q. No problem, right? Also, 0 is also in Q. So what else is there to check it is vector space? Multiplication, right? Take any element, like you have to take element from R and you have to multiply with the element of Q, and you have to still get the element. After multiplication also that should be in Q. But is that happen always? No, right? So for all element in Q, for all element, say let's say Q in Q, and small c belongs to R, C times Q should belong to R. But is it happening here? So let's say if I take an example, 1 belongs to Q and square root 2, that is belongs to R, but 1 times square root of 2, I mean, sorry, square root times 1, I mean, same, that is equal to square root 2, that does not belong to Q. So Q is not a vector space over R. Okay? And, I mean, you can prove that R is a vector space over R. I mean, don't take it difficultly. I mean, the main thing you have to remember that addition and then multiplication by the element, multiplication by any element from the field, I mean, from the space over which it is vector space, and 0 element has to be there in that space. Okay.
Yes, sir.
Okay, so if you understand that, then also vector subspace is, suppose W is a vector subspace of, sorry, let me write it properly. Vector, sorry. Subspace of V, where V is a vector space. Okay. If, I mean, A and B belongs to W, implies A plus B also belongs to W. and 0 is also in W. I mean, W is again a vector space. If it is a vector space, then it will be a vector subspace of a bigger vector space. I mean, the vector space it is.
Sir, you mean to say that all properties of vector would be satisfied by the vector subspace?
Sorry?
So you mean to say that all properties of vector subspace would be similar to that of a vector?
Exactly. I mean, if it is a vector space, then it is a. I mean, if it is a vector space, then it is a vector subspace of a bigger. If you have a bigger subspace, I mean, let's say, I mean, if I take 0, right? This is a set, right? 0 is a set. I mean, this is a set.
Yes, sir.
This is subset of R2, right? Sorry, R. R is a vector space, and here you see 0 is a vector space also. So we'll say 0 is a vector subspace of R. Let me give you another example. Let's say W is equal to xy belongs to R2 such that xy I mean, sorry, let me give you first easy example. Y is equal to 0. So W is a subset of R2, right? W is a subspace. Anyone wants to join? I'll just. Okay, so yeah, what we are doing? This W is a subset of R2, right? It is inside R2, right? It's what is R2? Your R2 is the whole one, all the this type of points. Now you have those points in W, which is x2 is equal to 0. So all the W will be subset of R2, whatever the element. I mean, the elements will be this line, right? I mean, this line only. We can check that this line, I mean, this W is a subset, is a vector space, right? Because if you take, let's say, x1, x2, any arbitrary point, and y1, y2, two arbitrary point. First of all, you have to check that 0, 0 element whether it is there or not. That is 0, 0 is belongs to W, right? Because xy, W has any xy with y is equal to 0. I mean, x equal to 0 also can be there, right? So 0, 0 is belongs to W, and x1, x2 belongs to W. Then what will happen? X2 is equal to 0 and y2 is equal to 0, right? I have assumed let x1, x2, and y1, y2 are in W. Then this has to happen from the definition of W. Now if I add x1, x2 plus y1, y2, that will be x1 plus x2 comma y1 plus y2, but y1 y2 are both 0, so x1 plus x2 comma 0. But this type of table are in W because x1 plus x2, that is some real number, and x1 plus x2 are a real number and comma 0, so that table will be there, will be in W. So that's how other property also, if you multiply by any element x1 comma x2, where x2 is equal to 0, so that will be cx1 times 0 because x2 is 0, so that will be again in W. So W here is a subspace because W itself is a vector space and it is inside one another vector space R2, which is, I mean, that's why it is a vector subspace. First of all, for subspace checking, usually the vector space has a very precise definitions and all using abelian group and all. But to check whether vector subspace, only you have to check that these three things. I mean, you add it, two element, if you add, then it will be also in the same set. 0 0 also has to be there, and multiplication by a scalar over which it is a vector space. Okay. So now you understand what I mean here?
Yes, sir. With respect to operation plus, no, sir.
Operation plus, addition plus. Yeah.
Okay, sir.
I'm not going in the very detail here. I mean, yeah, of course, here the operation is plus, and another operation is there, that is scalar multiplication, right? So it is. So we say vector space which is closed under addition, and multiplication, but multiplication by scalar. Scalar mean, we say the scalar means scalar belongs to the field, or I mean as a set over which is a vector space. Okay, over which is a vector space. The scalar will be from over which V is a vector space. V is a vector space. Okay? I mean, if it is a vector space over R, then the scalar is any element of the R of that real number set. If it is over some other number, then it will be, I mean, it will be from that scalar will be from that set. Any other question here? Tell me.
Sir, when we say that the vector space is R square, R to the power 2,
Yes.
sir, then in that case, scalar would be from R to the power 2?
No, scalar is from R. That usual. When usual have to be like that only. If you take, see, R2 is a vector space over R. I mean, if you have, see, generally what you see, if you have, let's say, you have 1 and 2 points. I mean, it is called 1, 2 point. Let me draw. Suppose you have, this is 1 and this is, you go 2, 1 and 2. Let's say you have 1 and 2 points here. This is a vector 1 and 2, right? If you multiply by a scalar, let's say 3, I mean 3 is from where? 3 is from real number. Then it will go up to 3 and 6. I mean, it will go to 3, 6 point. If you multiply by half, it will reduce to half and 1. If where is R, half is in minus, half is in R. If you multiply by minus 1, so that has to be in, that will be minus 1, minus 2. So, I mean, minus 1, minus 2. So, if R2, usually when we speak, that if you take one element, if you take one element, if you multiply and if you add, those things will be also in R2. But if you say R2 over R2, then you have to define how you are multiplying by. So if you have 1, 2, you have to multiply by it by one number here, that some, let's say 3, 4. So how you then multiply this, that has to be also defined in that case. So that's why usually when you say R2 is a vector space, that is R2 is a vector space over R. That's all. Understand?
Yes, sir.
Okay. So any other question?
No, sir, not now.
Okay. Now, yeah. So R2 is a vector space over R. Then we write like this. So we have seen R is a vector space also over R. So you can check that complex rate of all complex number, that is also where that will be also vector space over R. You can check. Okay. So now what I want to say, so suppose you have a W which is X, Y, those, it contains those elements of R2 such that X, Y is equal to 1. And W is then subset of R2. Sorry, subset of R2. It is a subset. So can you say that whether W is a subspace? I mean, in other sense, whether W is a vector space. Okay. Can you check 3 properties? There are 3 properties. Ravi, please check. I will give some time. Is it okay? You check, want to check, or I will read.
Sir, 0 does not belong to this
Great,
W.
great, great. Yeah, the first one is I thought you will be trying some other thing also. I mean the other property also. Okay, so 0 has to be in W if 2 has to be vector space. 0 is not in W, right? Because 0 times 0 is not equal to 1. So this W is not a vectors subspace of R2, right? So that it becomes very easy. So these type of questions are there in your assignment also. Not this type of. I mean this using this funda. I mean this concept. Okay. So I will give now then the assignment question. One assignment question based on this. So let's say I have a question. This W1 is equal to x, y, z is there in R3 because R3 also any Rn is also vector subspace of how many over R such that y is equal to minus 4x and z equal to 6x. Can you tell me whether this is a vector subspace of R3? W1 vector is W1 vector subspace of R3. It's a subset of R3, right? Now tell me whether it is a vector subspace of R3.
Yes, sir, I think it is.
How? You have to verify. It's not I. Yes, I think, right?
Sir, if we take x as 0, then we get y as 0 and z as 0. That means 0, 0, 0 belongs to W1. So, sir, that first property is satisfied.
True.
After that,
Good,
hello, sir.
good. 0, 0, 0. Yes. Tell. Now tell. 0, 0 in W1. That is correct. Fully
Uh,
correct.
so then we take two other elements from our W1. Let's say the x value is 1. So we will get y as minus 4 and z as 6. And
But you have to do it for any element. That you remember, na? You have to do it for any element. You cannot take here example. These here you can only for say for only 0, 0, 0. But other property has to satisfy for any two elements.
okay, sir.
You understand? When by taking x equal to 1, you cannot only prove. You have to do it for any x. So this one I will tell you how to do it easily. See, you see once this W1 has those elements x, y, z such that y is equal to minus 4x, z equal to 6x. So can't you write this quantity as x minus 4x 6x such that x belongs to real number. Can't you write that these two are not these two are equal?
Yes, sir.
Okay, so once you got this, then it is now becomes easy. So if you take, I mean x W1 in W1 you take any two elements, two vectors. Let's say x bar, y bar belongs to W1. But how will they look like? X bar will be something like x1 minus 4x1 and 6x1, right? Y bar will be some y1 minus 4y1 and 6y1, right? Now if you add x bar plus y bar, what will be that? X1 plus y1. If you add components minus 4 times x1 plus y1 and 6 times x1 plus y1, right? So what is this? This belongs to w1, right? Because x1 plus y1, that is in real number, because I started with x1 y1, those are real numbers. x1 plus y1 will be real number, and then what you see, one real number and comma minus 4 times that real number and comma 6 times that real number, right? And that is what the definition of a w1. W1 has those elements which has x times x minus 4x and 6x, where x belongs to real number. Here also you see x1 plus y1 minus 4 times x1 plus y1, 6 times x1 plus y1. All those are real numbers. x1 plus y1 are real numbers, right? So it is in W1. And now you multiply with some constant c, where c belongs to real number, then that will be also cx1 minus 4 times cx1, 6 times cx1. So you can easily see that this is belongs to W1 also. It becomes easier once you do this transformation, right? Otherwise it might look little difficult. I mean, you can, if you start with x bar is x1 y1 z1 like that, it might work, but no, see, it's okay, right? So this is how you can check that one set is a vector subspace or not. Ravi, you understand or?
Sir, got it, sir.
Okay, good. So then another example you do it, then you understand better. So W is equal to x, y, j belongs to R3 such that x square plus y square plus z square is less than equal to 4. What is W? W is geometrically, it's a sphere, right? Sphere of radius 2. So either this is a vector subspace of R3.
Sir, without example, I'm not able to get the second step, sir, where we do
Yeah, I mean,
two.
it will see when these type of things are there, we try to think in geometrically. So this is sphere, right? In the
Uh,
sphere, if you take 2 points, any 2 points, and if you add it, will that be in the sphere, same sphere?
Sir, I've taken 2 points, 100 and 200, which actually belong to the which belong to W, but their
Exactly.
addition does not belong to W.
Great, great. Yeah, that's how you have to do it. Yeah.
Sir,
So
but in can we prove it in general way, sir, like we did in last example, sir?
no, when you want to disprove, then you have to give example only, right?
Okay, sir. Okay,
You
sir.
cannot prove it. Yeah, you cannot prove it that it is a vector subspace. So if it's not vector subspace, then you give one example. That's all. It's very like logically, right? If you
Okay, sir. Okay, sir.
prove it, then you go to the examples. Do it like this process. But you cannot do this one. So you will see if you cannot prove that also. But by doing that, you cannot give the precise answer. That's why we give one example that you see here it's not happening. So there will be some examples where by which you can show that if you take 2 points and add it again, it will be in the vector space. But there are some points for which it won't happen. So that's why it is not a vector space. And you think when you think in the geometric way, then you can get the examples in like quickly you can get the examples. So it's like I mean, if you think in this, if you add a W which is in xy in R2 also, I mean it's a similar thing. R2 such that x square plus y square is less than equal to 1. Then what will happen? Your this is nothing but a this is a circle. Wait. Yeah. So this is a circle which has like 1 0 here, and it is you have 0 1. But if you add 0 0 1 plus 1 0, that will be 1 1, which is not belongs to the circle. Yeah, this W. So because 1 1 will be kind of here, right? This is a 1 1 point here. So this will not be the circle. So that you can easily check from the R2 itself, you can go to sphere and you can check it, right? So yeah, that's one another question here. It will be okay. So we'll give some other questions. Okay, so this type of example, leave it, and then okay. So let's say V is a set of all 2 by 2 square 2 by 2 matrices. Okay, 2 by 2 matrices. So this will be, then you can check easily check that V is a, can you check, like can you tell me that whether V is a vector space or not? Because if you, this is set of all matrices 2 by 2. So if you add two by 2 matrices, then it will be also 2 by 2 matrices. If you multiply with a real number, then it will be again, it will be multiplied by all the entries, and it will be again 2 by 2 matrices, and you have 0 0, all this one is there as a 0 element which will belongs to V. So V is a vector space. So now I am setting, I am giving a set A equal to those A, B, C, D that is belongs to V, and A plus D is equal to 1. I mean, one element of W is kind of 0, 1, 1, 1. That is belongs to W. One example, just example. So can you tell me whether W is a vector space? I mean vector subspace of W. If W is a vector subspace of V.
Sir, we can see that 0 will not belong to W.
Yeah, it's a 0 itself is not right.
Yes, sir.
Is it a vector? I mean, first of all, subset, right? It is a subset, right? No problem, subset. Yeah, I mean, 0, 0 itself won't belong. I mean, this question was from assignment question. Why it was? I mean, it's very easy for the first year, so you can understand that 0, 0 element is not there. Okay, so I think that's all from this part. I mean, the vector subspace and vector space. So I hope you understand, right? This is how we have to do. We'll either find an example to show that it is not a vector space. Otherwise, you try to show. You have to first tell that all the three properties I wrote that in this lecture. Those satisfy. Then it will be vector space. Means addition and multiplication by scalar addition, scalar multiplication by the scalar, and 0, 0 element. Means 0 element. Okay, and that 0 element can be 0 matrix for a matrix, set of all matrix. 0 element can be 0, comma 0 table for R2 and like that. I mean, whatever the property. 0 element means after if you multiply by any other non-zero element, any other element, it should be that element. If you add 0 element to any other element, the element won't change. I mean, it will be same. That is the definition of 0 element. Okay. So there is something called linearly independent and linearly dependent. Do you know that?
Sir, can you please give the overview, sir?
Yes, yes. So if you have, I mean, element of a vector space, element of vector space is called vector, right? I mean, matrix is a vector, right? Because matrix, I mean, if not every matrix, I mean, on matrix, if you have a matrix, then you can there will be one element of a vector space. If it's an element of a vector space, then the matrix will be a vector. And any function is which will be a vector. If it belongs to a space of functions which is a vector space, then that function is also a vector space. It means any element of vector space is called vector. Why I'm telling that? Now we come to any two vector. When we say only two vector, it's not only R2. It can be a matrix, it can be a function also. So now elements, suppose you have V1, V3, and kind of, I mean, VD you have belongs to a vector space P. If you multiply C1 by C1, C2 are elements from the scalars V2 plus CD VD is equal to 0 implies C1 equal to C2 equal to CD is equal to 0. Then we say V1 VD up to VD is linearly independent set of vectors. If this does not happen, if one of the C1 is not equal to 0, then it will be linearly dependent. Okay, that's called linearly independent dependent. We will see how. Let's say 1 1 and 1 1 and 2 2, they are in V which is equal to R2, and let's say R2 is that V. So can you check there whether these two are really independent or dependent? From this language itself, you can see it is linearly dependent by 2 because 2 2 can be written as 2 times 1 1, right? So what we can see always this C1 times 1 1 plus C2 times 2 2 equal to 0, that does not imply C1 equal to 0, C2 equal to 0, does not imply, right? Because minus 2 times 1 1 plus 1 times 2 2 will be equal to 0. I mean, when I write 0 here, 0 means 0 0 0 vector, where minus 2 is not equal to 0 and 1 is also not equal to 0. So we get two coefficients such that which are non-zero, at least one of them is non-zero, will be sufficient. So such that the linear combination, this is called linear combination. You are combining two vectors. That linear combination of two vectors is 0, implying both of them are 0. Then only it will be linearly independent, otherwise linearly dependent. So you can see from the visual expression also, if 1 1 and 2 2 is there, this is 1 1, sorry 1 1, then if you want to get 2 2, you can get it from 1 on itself. So 2 2 is linearly dependent on linearly also, because if you just multiply by 2, it will go to 2 2. Or another way, 2 2 is 1 1 is linearly dependent on 2 2. Because by multiplying half to 2 2, half times 2 2 will be also 1 1. So they are linearly dependent. Now keep 1 1 fixed and take 1 0. Can you say that whether they are linearly independent or not? Because 1 0 will be a kind of here and 1 1 you have here. Can you ever get 1 0 from 1 1? That's the question. We will prove that we cannot get linearly, we cannot get 1 0 from 1 1. This is 1 0, this is 1 1. We cannot get linearly by linear any combination such that 1 1 will be 1 0. Okay? We will see here why it is happening. See, if I multiply C1 by 1 1, see, we multiply 1 1 by C1 and 1 0 by C2, and if you make it 0 0, that will give you C1 plus C2. I mean, let's write properly, C1 comma C1 plus C2 comma 0, that will be 0 0, and that implies C1 plus C2 comma C1 is equal to 0 0. And when two vectors are equal, then there has to be component wise 0. So component wise has to be also equal. So that implies C1 equal to 0 and C1 plus C2 equal to 0. That implies C2 is equal to 0 from, because C1 is equal to 0. So if I take for these two vectors, if I start with this linear combination, then C1 and C2 has to be 0, and that's the definition of linearly independency. And that's why it is not linearly dependent. They are linearly independent, and you cannot get linearly 1 0 from 1. Do you understand this?
Yes, sir.
Yes or no?
Got it, sir.
Okay, okay. If you have any other question, you ask me. Otherwise, I will stop it here.
No, sir. I am yet to solve the questions, sir, from this week, sir.
Sorry?
So I am yet to solve the questions of this week, sir. I have not done it completely.
Yeah, I think all the questions you can do, because I can see that you are doing doing the questions. I have done whatever is they are asking. I have already done it. All type I have done, right, one by one. Or at least one I have done. One type I have done at least. In each type, one I have done, right?
Sir, there were some questions, sir. I think I couldn't understand them. So I think I'll have to go back and see. Sir, those were related to some polynomial degree and all those stuff, sir.
No,
I couldn't get related to this subspace only, sir. So I will have to see those questions again, sir.
okay. I don't know. I like whatever assignment questions I got. Like we are.
Sir, it's question 8 and 9, sir, in the assignment, sir. I'm not able to get.
Okay. Anyway, if check it, otherwise you ask me. Okay.
Yeah, sure, sir.
No problem.
Sir, should I ask it next time, sir?
Next time also no problem.